This video is the second part of Introduction to Organic Chemistry. This is about isomerism and types of reaction. Isomerism is a phenomenon where some substances have the same molecular formula but different structure. There are two types of isomerism. The first is structural isomerism. The second is stereoisomerism. For structural isomerisms, there are three types. The first is position isomerism, where the difference is in the position of the functional group. The second is functional group isomerism. The difference is in the type of the functional group. The third is change isomerism. The difference is in the carbon change. Position isomerism. Here we have some example of substances. We have 3 carbon atom with single bond. So this is an alkane where 2 hydrogen atoms are substituted by bromine. So here we have the group of the compound is halogenoalkane. The alkane consists of 3. The name is propane. Then there are 2 bromine here in carbon number 1 and carbon number 2. So the name of the compound is 1,2 dibromopropane. This is the first substance or the first isomer. The second isomer, the position of Br is in number 1 and carbon number 3. So here the substance is 1,3 dibromopropane. For substance number 3, we have bromine at number 1. So the name is 1,1 dibromopropane. And the last, number 4, in number 2. So the name is 2,2 dibromopropane. So we can say 1,2 dibromopropane with this structure, 1,1 dibromopropane with this structure, 1,3 dibromopropane with this structure, and the last, number 4, 2,2 dibromopropane with this structure. These 4 substances are 4 isomers of C3H6Br2. Or we can say 1,2 dibromopropane has 3 isomers, 1,1, 1,3, and 2,2 dibromopropane. The second type of structural isomerism is functional isomerism. For example, here we have a substance with 3 carbon atoms, and then functional group OH. So the group is alcohol or alkanol. The second isomer or the second substance is methoxyethane. Here we have 3 carbon with functional group O, and then the group is ether or alkoxy-alkane. So propan 1-ol and methoxyethane are two substances from different group. So they have different functional group. The first substance, propan 1-ol, has functional group OH. The second substance, methoxyethane, has the functional group O. So propan 1-ol and methoxyethane are isomers to each other. Why isomers? Because they have the same molecular formula. The molecular formula is C3H1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So the number of 8 is 8. And then 1O. The type of structural isomerism is change isomerism. Here we have the example CH3, CH2, CH2, CH3. This is the structural formula of butane. The group is alkane. And then methylpropane. The group also alkane. The molecular formula of butane is C4H10. Here we have C4H10. So butane and methylpropane are isomers of C4H10. Here we have question number 5 from your textbook. Number A, name the 4 isomers in figure 14.18. This is the figure. So number 1 is 1,2 dibromopropane. And then number 2 is 1,3 dibromopropane. Number 3 is 1,1 dibromopropane. And number 4 is 2,2 dibromopropane. Draw the displayed formula and name the structural isomers of C3H7Cl. So this is a halogenoalkane. Halogenoalkane. The halo is chloro, Cl, chlorine. The alkane is with 3 carbon is propane. So this one chloropropane. Number B. When we have 3 carbon then the position of Cl can be in this number 1 carbon, or in here the same, or in number 2. Then we draw the rest of the valence electron of carbon, because here the question is displayed formula. So we draw all the hydrogen. That's the displayed formula. This one is the substance number 1 is 1 chloropropane. The second is 2, because Cl position in carbon number 2. 1, 2. So here 1 chloropropane. The second is 2 chloropropane. The answer is this one of question number B. Number C, draw the displayed formula and name the functional group isomers of C3H6O. So if we refer to alkane C3H8, and here we have only 6 H, then there are 2 hydrogen substituted by oxygen. What we have with general formula CnH2nO, there are 2 groups. The first is aldehyde or alkanal. The second group is ketone or alkanon. So for C3H6O, then for alkanal is CH3, CH2, CHO. This is the functional group of aldehyde or alkanal. For ketone or alkanon, CH3, CO, CH3. But the question is displayed formula. So you just open the hydrogen. Double bond O, H, here with 2H, here with 3H. For the ketone, C double bond O, C. Here with 3, here with 3 hydrogen atoms. Continue with number D. Draw the displayed formula and name an isomer of C3H8O, or the general formula is CnH2n plus 2O. Here, the general formula belongs to ether and alcohol. So you can choose one of the group substances. For group of ether with 3 carbon atoms, then COC6. For alcohol, C, and then the functional group OH, or the OH can be in second position. You just choose one of the 3 isomers and then draw the hydrogen. Don't forget the name. Yeah. For the first, here the ether. If you choose the first, then CH3O, and then CH2, then CH3. The other name of ether is alkoxyalkane. Alkoxyalkane. So the main change is alkane. The main change is the longest change. Here, the longest consists of 2. Then the alkane is ethane. The rest, the carbon with oxygen, we name as alkoxy. Consists only 1 carbon atom. So the name referred to alkoxy is methoxy. Ethane. This is number 1. For alcohol, here, when the position is in number 1, OH. Please open the O and H, yeah, for displayed formula. And then here you have H, 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 H. Or the hydroxide, the OH, in position number 2. The same, yeah, just move to here. Then the name of this one is propan 1-ol. If the position in number 2, then the name is propan 2-ol. Number E, draw the displayed formula and give the names of the isomers of C5H12. So this match the general formula CnH2n plus 2. This is the group of alkane. Okay. Number E, I write the structure formula first. The first isomer, this is not the answer. The first with structural formula 5. Like this. I do not draw the H here. This is just a draft, yeah. Number 2, C, and then 1 branch here. Then number 3 is C with 2 branches here. So you just add the hydrogen. Yeah, the answer is just add the hydrogen. There are 3. And here for number E also the names here with 5 pentane. Here the main chain is 4. Then the branch is methyl or methyl in number 2. So the name is 2-methyl or methyl butane, yeah, butane. The last is 3. 3 is propane. There are 2 methyl here. This is for the name, yeah, not for the structure. This is propane. The branch 2-methyl. 2,2 dimethyl propane. Yeah, there are 2 methyl and dimethyl in carbon number 2 and number 2. The second type of isomerism is stereoisomerism. Stereoisomers are compounds whose molecules have the same atoms bonded to each other, but with different arrangements of the atoms in space. There are 2 types of stereoisomerism. The first is geometrical or cis-trans isomerism. The second is optical isomerism. For geometrical or cis-trans isomerism, this happens to the group of alkene. So the isomers have the double bond. And then the second condition is each carbon atoms in the double bond bonded to different atoms. Double bond and then each carbon atom bonded to different atoms. The molecular formula of the 2 substances here is C2H2Br2. But the position of Br in the first substance here side by side, or this one is cis 1,2 dibromoethene. In the second substance or the second isomers, the position of Br atoms is in the positions of trans. So the name of the compound is trans 1,2 dibromoethene. Optical isomerism. If a molecule contains a carbon atom that is bonded to 4 different atoms or group of atoms, it can form 2 optical isomers. We can describe this carbon atom as an asymmetric carbon atom because there is no plane of symmetry in its molecule. The 2 different optical isomers called enantiomers are mirror images of each other, and they cannot be superimposed. The carbon atom with the 4 different groups attached to it called the chiral center of the molecule. Here we have 1 carbon atom as chiral center. This carbon atom attached to 4 atoms or different group of atoms. First OH, the second methyl, hydrogen, and carboxylate. The same as this. This pair of molecules are optical isomers, referred to enantiomers. Trying to superimpose the 2 isomers is like trying to superimpose your left hand on top of your right hand. You can try. With them both facing downwards, it can't be done. Impossible. So your left hand and right hand are optical isomerism. Continue with question number 6A. 1. Draw the displayed formula and label the cis-trans isomers of butene. But is 4C and the group is alkene. 1, 2, 3, 4 with the double bond in second position in here. The question is displayed formula. So you draw all the hydrogen in each carbon atom. Here still has one. Here still has one. Here there are 3 hydrogen. So here for cis-trans, the condition, there are 2 conditions. The first is the substance has double bond. And then the second, the carbon with double bond attached to different, here, methyl and hydrogen. Methyl and hydrogen. Yeah, so there are the cis-trans of butene. How's the cis and trans structure? For cis, then the position of methyl or hydrogen at the position like this, displayed here. Hydrogen, hydrogen. The same side. Here you have CH3. This is cis. For trans, then different side. Double bond. Here the methyl. Like this. This is trans. Then you have hydrogen in here. This is trans. Cis and trans. Okay. Number 2. Draw the cis-trans isomers of 1 chloro, 1 bromo, 2 chloro, cyclobutane. Cyclo ya, cyclo with 4 carbon atom. Cycle with 4 carbon atom. Like this. And then draw the cis-trans isomers of here. No special question of displayed formula. You just ask the cis-trans isomers of 1 bromo, 2 chloro, cyclobutane or butane. So I want to draw in skeletal cyclobutane like this. And then the bromo in number 1. I choose this one. Bromo in number 1. Chloro in number 2. Here number 1. Here number 2. This is chloro. At the same side, then this is cis. Different side, then you have trans. Bromo and chloro. Yeah. One up, one down. One at the top, one at the bottom. Continue with number B. The molecule CHBrClF exhibits optical isomerism. Draw the 3D displayed formula of both optical isomers. the number of carbon only 1, the first, that's carbon. So 1 carbon and then attached to 4 different atoms. The first attached to hydrogen at the top, and then you need to draw Br, the second Br here, Br, and then the third is Cl, chlorine, facing towards you here. So in a long triangle, and then the bigger one, the bigger part here, facing to you. Here Cl, and then the last is fluorine at the back with this line. This is F, and then you need to draw the mirror plane. Then the second isomers is the image of the first substance or isomer. So when this substance facing mirror plane, then has the image of carbon, and then like the image of F in here, the image of Cl like this. This is Cl, and then right now the image of Br here for the hydrogen still at the top. So this is 3D displayed formula of both optical isomers. For number C1, which one of the following can have optical isomers? So the condition for optical isomers is that the substance has at least one chiral center. The chiral center is the carbon that attached to different atoms or group of atoms. Then check number A. CH2 double bond CH3. For checking the chiral center, we need to draw the displayed formula. So for A, CH2, and then this one here, double bond, and then C to H to CH3. I don't want to display the methyl because this absolutely not the chiral center, because the carbon attached to 3 hydrogen atoms, not different. So this is not a chiral. This one also not chiral because 2 valence electrons are attached to the left carbon. So this is not the chiral. For the left one attached to the same hydrogen, so this is not chiral. So number A has no optical isomers. Yeah. For number B, here I don't want to display the methyl because this absolutely not chiral, yeah, because attached to the same hydrogen atoms. So the CH3, I write as CH3. There are 2 here attached to carbon, and then here This is double bond, yeah. Double bond, and then CH, C, and H, and then attached to CH once again. The CH attached to Cl and CH3. Cl and CH3. So check one by one. This is not zero because the same hydrogen. Not zero. Not zero because two valence electrons attached to carbon, so the same. Yeah, the same. Then this is not the zero. This is zero. Why? Because this carbon attached to methyl, chlorine, hydrogen, and this, all of this. So this one the zero center. This one. Yeah, so the answer is B. For C, here, of course, this is not the zero because the same hydrogen, and then carbon also. Here there are 3 methyl attached to the carbon, so this is not the answer. Yeah, there is no zero center. Not zero center, not zero center, not zero center. And then here there are 2 Cl, 2 attached to carbon. So this is not zero. So D is not the substance with optical isomers. So it's wrong. The answer is B. Number 2, draw the displayed formula for the answer, yeah, of your chosen answer. Number B. Just open the hydrogen. Yeah, open the hydrogen. You have 2 CH3 attached to 1 C here, CH3. There are 2. And then this C with double bond. And then the double bond with CH. The CH to CH once again. And then the CH to Cl and CH3. Open, yeah, the CH3. And then the zero is this one. This one. Like that. So this is number 2.